Hi class, we're starting a new chapter today, chapter 3, which is probability. And what you're going to probably find with probability is it's going to start off seeming pretty simple, seeming maybe like a lot of review, but it will pick up. And it tends to be one of the trickier parts in the course. So I just want to encourage you to not underestimate the level of difficulty. Today won't be so bad. Section 3.1 won't be so bad, but it will pick up. So just know that probability tends to be one of the parts of the class that's a little more challenging. I really enjoy it, and I think I do a pretty good job of explaining it. So I'm going to give you some tips along the way that will hopefully help as we get into probability. First thing, you can see I have the definition here. Probability is the chance of a particular event occurring. We're going to put a number to that probability. So we're going to have a number that means, the probability of rain or the probability that a certain team wins. What I typically do when I teach this in person is we talk about what topics or what areas in life do we hear about probability or do we see probability. So one of them that I just mentioned was weather. So a lot of times we hear about the probability of rain or the chance of snow or whatever it might be. So that is one area that you might see a probability application. Another area that students usually bring up is gambling. And you can think of this playing cards, playing dice games, slot machines, the lottery, anything like that. There's a probability of winning any sort of game. Something you may or may not have thought of is probability in terms of illness or health. When you may go to the doctor and you are getting a particular treatment, they might give you a range, a percentage sometimes of the effectiveness of a particular treatment. So the probability that this particular drug is going to work, or the probability of this particular chemotherapy tied with this radiation, what is the potential probability for success for treating you and having you be healthy. A big area with probability is insurance. And depending on your age, you may or may not have thought of this one. With insurance, the probability of certain things occurring helps determine your rates. Let's talk about auto insurance, for example. Actually, I can just do auto, Auto insurance, they determine your rate, your premium, based on the likelihood that you're going to have a claim. So they have to decide, okay, how much do you have to pay? Because they're a business. They don't want to lose money. Well, they look at your age. They look at your gender. They look at the type of car you drive. They look at your driving history. All of those things will help them determine what kind of risk you are. Are you going to be likely to have a car accident or not? That's why I have two sons. Boys pay higher rates, or younger men pay higher rates. Also, do you have a sports car that can go really fast? They find that certain color cars might be getting in accidents more so than others. So those are all things that they take into consideration. Health insurance is another factor. Pre-existing conditions, as far as determining what your health insurance rates are. And then also life insurance, which again, depending on your age, you may or may not have really thought about that much. But if you have life insurance, it pays out if you die. So the determination of your premium is going to be based on what kind of a risk there is. And in the insurance field, there is a job called an actuary, which at one time, I didn't look it up recently, was the highest rated job as far as job satisfaction. And this person has a statistics degree, and then there's a bunch of certification tests that you have to take, but they determine those rates. So they look at what's happened in the past to use probability to determine the insurance rates. Probability in sports is another area. Looking at things like batting average, what's the likelihood that this player is going to, hit a home run, or what's the likelihood that this player is going to strike out. My sons are both into sports analytics, and they are following statistics degrees and hoping to connect them with the sports field. And I'm going to put an etc. because there's probably some I haven't thought of. So you can see that probability is going to connect in many different fields, and you're going to see examples as we go through the course that fit in those different fields. Okay, probability can range from a number of 0 to a number of 1. If the probability is 0, that means there is no chance of the event occurring. It is impossible. And what you're going to find is that there are very few events that are truly impossible. I used to use the example like, what's the likelihood that we won't have school tomorrow? Well, think about what's going on now. Who would have ever thought with COVID and the shelter in place and the quarantine that things would be where they are? So that no chance, okay, maybe it was a slim chance, but it actually happened. So impossible events, probability of 0. If an event is certain to happen, it's guaranteed. I'm going to put for sure. Then it has a probability of 1. So these are rare and these are rare. Most of the time, probability is somewhere in the middle. And those middle values in between are, if you think about it, fractions or decimals. So typically you will see probability listed as a fraction, like halfway would be 1/2, or you could use 0.5. Or, it could be something like 1/4, 0.25. It could be 1/10, which would be 0.1. Okay, could be 0.99, which would be really close to 1. Not certain, but really close to certain. High probability. Sometimes you will see probability as a percent. So let me do this. Probability can be expressed as a fraction or a decimal or a percent. Most of the time, we like the decimal way. That's going to be the way that helps us the most. And you think about it, it's going to range from 0 to 1. It's never going to be higher than 1. It's never going to be lower than 0. There will be some problems where on the My Open Math, it'll ask you for a fraction. You always want to write it in lowest terms, and you'll see that in my examples. Every once in a while, they'll ask for a percent. So you think about, you could have 1/4 for a probability, which is 0.25 for the decimal. And then if you move that decimal 2 places, that's 25%. So most of the time I want to see this part. You might notice on My Open Math, there's a couple of them where they will ask you to take the decimal and change it to a percent. Again, most of the time we like looking at the decimal. Okay, one other thing, and then we'll start doing some examples. I want to talk about when something is unusual. If something is unusual, we're saying it's rare. It's unlikely to happen. So I'll say unusual events are rare, unlikely to happen. It doesn't mean they're impossible. It just means it's a very low probability. So it's very unlikely to happen. And what we're going to say here is that an event is unusual if its probability is less than 0.05. Okay, if we made that a percent, that would be 5%. I could say here the probability is less than 0.05. And I want to put this in my picture because I want you to realize something. Halfway is 0.5. This is really common. Okay, you have a 50-50 chance of something to happen, a 1 out of 2 chance. Okay, the 0.05 is way the heck down here. It's really close to 0. That's where the unusual stuff is. The values that are really close to 0. And let me just fix this, it looks a little messy. 0.05. It would be like a 1 out of 20 chance. So every once in a while, students will inadvertently write 0.5, which is 50%. That's not unusual. That's not a low probability. So just be really careful with that. I've seen students inadvertently make it a 0.5. It's a 0.05. 0.05. And then let me just put a little box around this. Because in your notes, this is going to be something that will come up. All right. So now we're going to do several examples. And again, they're going to start off probably a little more basic than you think you need. What we're getting used to is terminology. What we're getting used to is notation. So don't worry, it is going to pick up. All right, I'm going to clear this and we're going to do our examples. So the first example. I'm going to say example 1, flipping a coin. When you flip a coin, you can get heads or tails. So you have 2 options. It's a total of 2. If I want to know the probability, and I'm going to put a P here, and then inside, that's the thing that I'm trying to find the probability of. When I flip a coin, the probability that it flips up to heads. So this means the probability that we get heads when we flip a coin. You could also go probability of heads. And when we're finding probability, we're going to take the probability of what we're looking for, and it's going to be the number of times the event occurs. Ooh, that's not good. Over the number of trials, or what I'm going to put here is I'm just going to put total. Okay, the number of times the event occurs. So we're trying to find the probability of heads. Well, we can either get heads or tails. There's one that is heads out of a total of 2. And I think you guys have probably worked with this before. So the probability is 1/2. If they wanted a fraction, we leave it as 1/2. If they want a decimal, it's 0.5. And is this unusual? Well, think about it. If it's unusual, the probability is less than 0.05. Excuse me 1 second here. So this probability would not be unusual. It would be usual. It would be very likely to flip the coin and get heads when you flip the coin. If we wanted to take the probability of tails, it's also 1 out of 2. There's 1 tail out of a total of 2, and that adds 0.5 also. What I want you to notice, and this is going to come up in the next section, if I add these 2 probabilities together, 1/2 plus 1/2 gives me 1 whole. 0.5 plus 0.5 gives me 1 whole. You're going to notice when you show all the different options, they will add up to 1. So either this is going to happen, you're going to get heads, you're going to get tails. Those are the only 2 possibilities. Okay, another example. Number 2, we're going to look at rolling or throwing, depending on how you think about it, a die. Let's say rolling. Not a pair of dice, a single die. And we're going to assume that it's just a normal 6-sided die. So when you roll the die, you're going to have the options of 1, 2, 3, 4, 5, or 6. So your total, you have 6 different possibilities when you roll the die. Okay. So we're going to say, let's find the probability that you roll a 1. This is making me think of aggravation for some reason, the game aggravation. I think you need a 1 or a 6 to get your guy out of home. So the probability that you roll a 1, there's 1 out of the total of 6. So this would be 1 out of 6. We would make sure that that is simplified, and it is. And if we want to change that to a decimal, it's 1 divided by 6, and we get 0.167. Again, with the rounding, I'm not real nitpicky about the rounding. Just watch it on the online work because it's going to be more specific. Now let's say it asks for the probability that you get an even number when you roll the die. Well, if we look at the even values, 2 is even, 4 is even, 6 is even, so this would be a 3 out of 6, which is a 1/2. So if they wanted a fraction, we would simplify it. That would turn out to be 0.5. And when I look at these, to me, this is the work, this is the answer. Now, some of them will want a fractional result. I typically want the decimal. This is easier to work with. And students usually like working with decimals more so anyway. So I would say this is your work. So I can see numerator, denominator. There's your work. There's your answer. Okay, the last one, let's say, what's the probability of a 2 or a 5? Well, there's a 2. There's a 5. there's 2 options out of 6, which would be 1/3, and this is going to be 0.333 repeating, okay? If we look at these, are any of them unusual? Are any of them less than 0.05? No. So all of these would be likely rolls, likely combinations. And something I want you to think about, which I need to plug in my laptop real fast. My battery is dying. Okay, that should be better. When we're talking about rolling a die, I want you to think about little kids. In games, sometimes they'll talk about, oh, 6s are really hard to roll. A 6 is as likely to roll as a 1 out of 6 chance. So understanding that kind of can make a big difference. You know, that's kind of a maturity thing, a developmental thing. Also, if you are a gambler, there are games like craps, for example, where 7 is an important number. There's lots of ways, there's lots of probabilities, or the probability of rolling a 7 is high. 1 and 6 is 7, 2 and 5 is 7, 3 and 4 is 7. So some of the odds or some of the probabilities involved in winning and playing those games, you would need to understand the math behind it. Okay, I'm going to do a couple more examples. Let's see, let me clear it off this way. A couple students in the last check-in had requested more examples, so I am going to give you a few more. Something you may or may not be aware of, down when you're playing the video, you can play it on a faster speed if you want. I realize it makes me talk really fast, but if you're feeling pretty comfortable with it, you could go a little faster, and then if you hit a point where it looks a little trickier, you could slow it back down. Okay, next one we're going to look at grades on a test. And I have not graded your test yet, but let's say I had, and then I posted this. There were 15 A's and 7 B's and 7 C's and 4 D's and 4 F's. Okay, so you see that, and in your mind you're saying, oh, I wonder how I did. So we're going to look at this, and let's say you said, what's the probability that I got a C on that test? And that's what this means. This notation means the probability of this happening. So what we would do, the probability of a C, we're going to need the total down here. And the total is what? 15 and 7 is 22, 29, 33, 37. And we're going to say, okay, probability of getting a C is a 7 out of 37. That would be the work. Now, if this could be simplified, we would. It can't. On My Open Math, they may ask for a simplified fraction. For me, you're going to take the 7 divided by 37, and we get 0.189. And I'm going to put a squiggly. That means approximately equal to 0.189. And if we think about that, is that unusual? No. The probability is not less than 0.05. If we think of that continuum from 0 to 1, the 0.189, maybe it's like right here. It's not that close to 0. So it's pretty likely to happen. Probability of getting an A. Well, there's 15 A's out of 37. So the likelihood that you got an A is going to be pretty high, 0.405. Let's say you're like, I just want to pass. So we're going to say C or higher. Well, there's a C, there's higher than a C, and that's higher than a C. So we could have any of those 3. So what's that? 14 and 15 is 29 out of 37. So the likelihood that you got a C or higher is 0.784. Still very likely. And then let's say you came in and you're like, I just don't want an F. So I'm going to use the word not F. Well, if you're not getting an F, you could be getting a D or a C or a B or an A. So there's two ways you could do it. One way is you could add all these up. The other way is you could take 4 away from the 37. It's going to be 33 out of 37. 0.892. So the likelihood, 0.892, think of that, that's way over here. The likelihood of that you didn't get an F, did not, is pretty high. This concept of looking at this, and if I say not, we're going to talk about, it's called the complement, and that will be coming up in the next sections. Okay, let's do, I have 2 more examples. So the next example, often when I'm teaching this in spring semester, it's around Girl Scout cookie time. And usually when I do this in class, I bring in the cookies and we talk about it. So obviously we can't do that now. My nieces are Girl Scouts, so I support them that way, and then also save myself having all the cookies at my house. So there are trefoils. I don't usually buy those. Those are the shortbread cookies. And let's say this is the like the Girl Scout, their little booth that they have set up. And there's 5 boxes of trefoils in their booth. And Samoas, which are my favorite, those are the ones like coconut and chocolate. Hang on a second. The Samoas, let's say there's 15 of those. Tagalongs, I like those too. Those are the peanut butter and chocolate. Let's say there's 35 boxes of those. Thin Mints, those are okay. My sons usually get those because they said there's more cookies in the pack. So you get more free money. And then Do-si-dos. And those are the peanut butter sandwich ones. Just peanut butter, no chocolate. Making me hungry. So here's the booth. They have these boxes, and we're going to find out some probabilities. What's the probability? And what you can do is just think about they had a big box and you reached in there. What's the chance that you pick out a box and it's a Samoa? Or what's the chance that you picked up a box and it's not peanut butter? Or doesn't have peanut butter? What's the probability that you get a box of Oreos? What's the probability that you get Samoas or Tagalongs? What's the probability that you get a box of Girl Scout cookies? And the last one, what's the probability that you get the trefoils? If I'm saying that right. Okay. A suggestion, sometimes when you're reading the problems on the computer, if it's given to you in a paragraph, like written out, it's a good idea to just summarize what they give you. Sometimes they give you the total, sometimes they don't. And be careful to look at that on the MyOpenMath. So I'm going to get the total here, and that helps me organize things. So it's this 5, 10, 15, 3, 4, 5, 9, 10, 105. Get that guy out there. So there's 105 boxes of cookies. So the chance that we grab a box of Samoas, there's 15 out of the total. So this would be 15 out of 105. Now for me, you take that 15 out of 105, make it a decimal. On My Open Math, they may want a simplified fraction. So if we divide by 5, you get 3. And if you divide by 5, oh, we can divide by 15 actually, huh? We divide by 15. 105 divided by 15 is 7. So this would be 1/7. 15 out of 105 is 0.143. And again, typically for me, you're going to have this part and you're going to have that part. This is your work. This is your result. And is this unusual? Nope, it's usual. Normal. Not rare. Now we say, what is the probability that we get a box of cookies that does not have peanut butter? My niece is allergic to peanuts, so she can't have peanut butter. So we want to make sure she gets a box of cookies that doesn't have peanut butter. Well, these are peanut butter, so those are out, and these are peanut butter. The mints are okay, there's 40 of those. The Samoa is okay, there are 15 of those, and the trefoils are okay. So if it's not peanut butter would be this one, or this one. So it's at 40 and 60. Again, if we want a simplified fraction, divide by 5. Again, let's see, divided by 5 is 12. Divided by 5 is 20. Oh, we could do the 15 again. I keep not recognizing that. Divided by 15 is 4 and 7. And then your 60 divided by 105 is 0.571. And again, if it doesn't say on the rounding, you can decide how to round it. I would say like 3 or 4 places is usually pretty good. You usually want to go more than 2 so that you can compare it to the 0.05. All right, this is a good problem right here. What's the chance you're going to get an Oreo, a box of Oreo cookies out of this box? There aren't any. So the probability is 0 out of 105, which is 0. It's impossible. How are you going to get Oreos when you're at a Girl Scout cookie booth? So that's not going to happen. Now, you could argue, oh, what if somebody threw one in there or something? But based on what we're given, that would be impossible. Next one. What's the probability of Samoas or tagalongs? Samoas are 15, tagalongs are 35. These are my 2 favorites. So we'd have here the 15 plus the 35, which is 50. Divide by 5, divide by 5. 0.476. And again, if you didn't have that, that would be okay with me. The only time you really need the simplified fraction is if it's requested on My Open Math. What's the probability that you're going to get Girl Scout cookies? These are all Girl Scout cookies. So 105 out of 105. 1. It's guaranteed. It's for sure. It's certain. And then this last one, what's the chance you're going to get trefoils? Well, there's 5 of those out of 105. So this would be 1 out of 21. 0.048. This is the first one that is unusual. Here's why. 0.048 is smaller than, less than 0.05. And at this point, you should be comfortable. And actually, that makes it look like a less than or equal to, and I don't want it to look that way. You should be comfortable with that symbol, but my experience has shown me a lot of people aren't. That is a less than symbol, and it means this number is lower, the smaller part, than this number. The wide part is by the bigger number. The tiny part is by the smaller number. Sometimes it bothers people. Let me show you something you can do. See how this has 1, 2, 3 digits? This has 1, 2. I can put a third digit there, just add a 0. This number is 48. This number is 50. You can see that it's less than. So what tends to happen, most of you are like, I'm fine with that. Well, not even every once in a while. There might be 2 or 3 students in the class that are like, those less than, greater than signs mess me up. So if you know you're one of those and you need a little extra support with those, come to me during office hours or lab time or email me. Okay, so this is unusual because the probability is less than 0.05. It's pretty close to 0. Okay, last one we're going to look at. We're going to talk about the chance of winning the lotto, winning the California lottery. And as a math person, I don't play. I mean, yeah, every once in a while I've played just kind of as a little, I don't know, something fun every once in a while. But I know the odds. I know the probability. And I don't feel like I'm going to win. So I'd rather put my money somewhere else. I looked up the probabilities. Super Lotto is a 1 in 41,416,353 chance of winning. So the probability of winning the Super Lotto is 1 out of 41,416,353. Okay, we're going to do that on the calculator because I want to show you what happens with that. Let me see if I can share that this way. Okay, let me pause this for a second and then I'll share the calculator. So make sure you have this number written down. Okay, I have my calculator up now, and we were looking at the probability of winning Super Lotto. Winning Super Lotto. And we said that was 1 out of 41,416,353. Okay, so let's put it in our calculator and see what we get. So I'm going to clear my screen. And we're going to do 1 divided by 41,416,353. Okay, look at that number. Kind of weird, huh? We talked about probability being smaller than 1. It's in between 0 and 1, but we have this 2.41. 2.414505208, and then it's got this E -8. I wanted to make sure you saw this. Here's what it means. I think you could see here that the probability of winning the lotto is very low. This number is so small. It's not 0, but it's really close to 0. and it has a bunch of digits that don't fit in the calculator display. So your calculator still wants to give you the result. And what it does is it gives you the result in scientific notation. And here's what that means. It means 2.414505208. See where this E is? That means times 10, and that's the exponent to the -8. And this again is called scientific notation. You've probably worked with it in your past math classes. What it basically means is that where this -8 is, your decimal is going to move 8 places in the negative direction on the number line. So it's going to move to the left. So what we're going to do is we're going to take this 2.414505208 and we're going to move the decimal 8 places to the left. 1, and then we're going to have 7 more. So those are going to be zeros. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Oh, 8. I knew we were missing something. So we move the decimal 8 places. Let me just check again. 1, 2, 3, 4, 5, 6, 7, 8. The first place moves it past the 2, and then the rest are zeros. So that's why there's 7 zeros. So this is what that value is. 0.1234567 zeros. 24145052008, and it probably would keep going. That doesn't fit in the calculator display. So that's why it gives us the number in scientific notation. From my end, I don't want to see the E. That is a calculator notation. That, if you just write it down with the E, it tells me you copied it out of your calculator, but you really don't know what it means. You can list the result in scientific notation, or you can list the result as a decimal. Both would be acceptable. So if you're going to list your result, you can either have this number or this number. And what I want you to realize is if you're doing this number and it tells you to round, let's say it says round to the 10,000th place, 4 decimal places. Well, if we go 1, 2, 3, 4, this is pretty much 0. So even though it's not exactly 0, it's really close to 0. It's pretty unlikely. It's very unusual. So this is less than 0.05. So we're going to say this is unusual. So yes, it would be unusual to win the lotto. And I think you know that. Let's do another one because I want you to see how this works. Let's do, this is the probability for winning Mega Millions. I don't play, so I don't really know these games. And if you go online, it'll tell you the probability for the scratchers and everything. So you can see all of that. 1 out of, it's a little bit better, 302,575,350. So this is 1 out of 302,575,350. So if we do that in the calculator, I'm going to go 1 out of 302,575,350. Again, we get that scientific notation. What happens a lot of times is students just write down this first part. They don't look all the way to the end of the number. What I want you to realize, the highest that probability can be is 1. So if you see that 3, something is wrong. Keep reading. Common mistake. So this is equal to 3.305, say, times 10 to the negative ninth. I put in the times 10. This would be an okay way to express it. The other way, move the decimal 9 places to the left. So if we move this 9 places to the left, there's going to be 8 zeros. And again, you can see this is a very low probability. So the likelihood of it happening is very small. It's unusual. If they wanted you to round it, it would come out to be 0. So it's just barely above 0. I wanted to make a point of showing you how these look on your calculator because it's a common area that students they feel like they do something wrong. They've done something wrong because they realize the probability shouldn't be that high. And I just want you to look for that because as we move forward, we're going to see a lot of really low probabilities when we start hypothesis testing. And I want you to make sure you can recognize those, and they'll actually be a good thing when you have them. So watch for that. There's one like that on the paper homework. I don't think you'll see any on the MyOpenMath, but there's one like that on the paper homework for sure. Okay, so that's our introduction to probability. Again, it's going to build, so make sure you really understand the foundation before we move forward with it. Have a good rest of your day.